In video A, we focus on facts we need to remember about probability distributions. We'll look at expected value of discrete random variables, and then we'll also look at our binomial PDF. Please rewatch any parts of this video. Again, we are going to zip through it pretty quickly. But to begin, we're going to start with a key idea of probability distributions. This is what they look like. It's a sample space where you have your possible outcomes in the top row. It's usually a table display. And in your bottom row is your probabilities. And there's some facts you need to remember about these probabilities that are listed below this table that we should take a look at. So the first is that the sum of all the probabilities in our distribution should always add to 1. So that's how we're going to do our first example today. All probabilities, like we mentioned in class the other day, have to be a number between 0 and 1, fraction, and probability distributions can be given in a table, a graph, or a probability mass function, but most cases you're going to see it tabular like we do in this above example. So let's take a look at one example that uses a probability distribution. They ask us to find the value of k in the following distribution. I see that k represents a probability for our value of 1. So if I want to solve for k, I know that all these probabilities have to equal 1 altogether. So I'm going to do 0.3 plus k plus 0.5, set it equal to 1 to find this possible probability. And we get that k is equal to 0.2 for our first answer. Sometimes the table isn't formed yet, like you see in example 2. All they're giving us is the probability density function, P of y equals y. They're just saying the elements of y equals y follows this rule, C of y to the third power. And they're giving us the y values to input for our possible outcomes. So our first row for y is y can be 1, 2, or 3. And then we start filling into the rule. So if y is 1, filling in y, it's 1 to the third power times c. I get c times 2 to the third power if y was 2. And plugging in 3, we get c times 3 to the third power. So that does simplify a little bit, and that's what we'll fill into this probability density at the bottom row. So 1 to the third power is 1, so this reduces just to c. 2 to the third is 8. We get 8c, and 27c for our last cell. And now if I want to find the value of c to make these probabilities work in a distribution function, I'm going to set this bottom row equal to 1 and solve for c. So I get c plus 8c plus 27c all equals 1. And this boils down to 36c equals 1, or c is equal to 1 out of 36 for our final answer. Okay. In part 2 of this video, we're going to look at expected value of a discrete random variable. If I'm asked to find an expected value, or if I'm given an expected value for a discrete random variable, there's a certain formula that I need to follow. This is what it looks like in your formula booklet. It's a little weird to look at, but when I'm given it in a table, it's a little easier to work with. So if we look at example 2, we'll work through how we deal with problems like this. So the random variable v has the probability distribution as shown in the table, and e of v, the expected value, is given to us. E of v equals 6.3. So what the expected value formula tells us to do is you're going to take the possible outcome. So for the first term, in our case, 1. This is from the first column. And you multiply it by that outcome's probability. So 1 times 0.2. Then I'll work the second column. So I get 2 times 0.3, and we add in between every time. So to follow the pattern for the rest of the terms, we would get 5 times 0.1 plus 8 times 0.1 times k times 0.3. Then you want to reduce wherever you can, so we still have this 6.3 is equal now to 0.2 plus 0.6 plus 0.5 plus 0.8 plus 0.3k. We get 4.2 equals 3k, and our k value is equal to 14. You probably would want to use your calculator for a problem like this, so I would see this more on a paper 2 context. Okay, so that does it for our expected value and probability distribution functions. When you flip over to the next slide, we'll take a look at binomial PDFs and how you deal with that. You would have to use your calculator for a binomial PDF. Remember, we always use binomial PDFs when we're finding an exact probability value. So if it's an at least or at most, that's going to be video B for you today. If you're interested in seeing that, that's a binomial CDF. But I'm going to be focusing on binomial PDFs for this video because I want exact outcomes. You'll have to use your calculator, hit second vars. And binomial PDF is in the scrolling section. You have to scroll forward a little bit and search for it, but we do choose PDF for exact. Think of it as P is for perfect. Okay, we want the perfect exact value of a probability outcome. So you're going to find your trials. You're going to get 3 different values when you're working through a problem. You need your number of trials, that's your N value. You need to know the probability, so depending on the context, or they might have to give it to you, and you want the X value, whatever you want exactly of. And then you hit enter in your calculator to get your answer. You can either show the formula from your formula booklet or show exactly what you're plugging into your calculator to get it done. On your IB exam, you definitely want to show the steps, especially if this is worth more than 1 mark. You want to show what you're actually plugging into your calculator and be very clear. So let's take a look at example 3. X is binomially distributed with 6 trials and a probability of success equal to 1/5 at each attempt. So if I have 6 trials, they're giving me an N value. And when they're telling me the probability of a success, they're giving me my probability is 1/5. And they want to know the probability of exactly 2 successes. So now they're telling me my X value or my exact value is 2. So in our calculator, we're going to be plugging in for our binomial PDF. And if you need to pause the video, make sure you can click these buttons correctly on your own. You should do that. I have a binomial PDF of 6, a probability of 1/5, and an X exact value of 2. And when you type that in, enter, 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 0.24576, write the full decimal, or 3 sig figs. Okay, if you want to try the next 2 on your own, you're welcome to do that. I'm going to continue with the video, so if you want to fast forward a couple seconds, you're going to be a couple seconds ahead of me, and I'll catch up to you. If not, continue watching. So now I want exactly 1 success. So if I want exactly 1 success, now I have an X value, X equals 1. So that's just going to change my plugin. You would have to show this binom PDF that you're filling into your calculator. My number of trials is still 6. 1/5 is still my probability, but this time I want exactly 1, so I fill that in. Type that into your calculator in your binom PDF, and we get 0.393216 for our final answer. And if they're asking us in part C for 1 or 2 successes, well, in part 1, we found what happens for the probability for 2 successes. In part 2, we found a probability for 1 success. So in part 3, if I want either or, I'm going to add those 2 values together. And together we get 0.638976 for our final answer. Okay, so you have 2 problems to try on your own right now with reflecting on what we did in this video. So the answers will be up online. If you'd like to go ahead and do them, check them out. If there's any questions in class, let us know any further. Thanks for watching this video. Watch your second.